The first topic of this lesson is all about Azure SQL Database service tiers. How much compute resources our database get made available to them, and how much it's going to cost us. Azure SQL Database has got three different service tiers which define the size, performance, the features available, and, possibly most importantly, the cost of an Azure SQL database. These tiers are Basic, Standard, and Premium. Now, performance in Azure SQL Database is often measured in something called database transaction units. They're used to measure performance on an Azure SQL database. We will look at what a DTU is later on in the chapter. So we will start with the basic service tier. This is the lowest tier available to us. You'd use the basic tier for small, infrequently used applications that are not supporting a huge number of users. Got quite a restrictive limit on the features available in your Azure SQL database. For example, it's got a maximum of 5 DTUs and a database size limit of 2 gigabytes. And the cost of the basic tier is reflected in that. Basic tier comes in at around about $5 a month. The standard tier is the most commonly used service tier across the Azure stack, and it's commonly used for things such as web applications and workgroup applications. Now, unlike basic service tier, it has got 4 performance levels: S0, S1, S2, and S3. In terms of the database size, the limit is the same across the 4 levels. So S0, S1, S2, S3 service tier levels all have a maximum database size of 250 gig, but they differ in terms of the DTUs and cost. So S0 through to S4 offer 10, 20, 50 and 100 DTUs respectively, and the cost of each level differs as well. So S0 comes in at around $15 a month, S3 comes in at around $150 a month, and then S1 and 2 fall somewhere in between. The premium service tier is what you're going to use for your mission critical, high transaction volume applications. It supports a large number of concurrent users. It has a high storage performance compared to, say, basic and standard, so you get a lot more I/O throughput. There are 6 different performance levels, as you can see from the screenshot there, going from P1 through to P15. Each performance levels offers a different maximum database size. P1 to 6 there, the maximum database size is 500 gig. P11 and P15 have got a maximum database size of 4 terabytes, so quite a significant database size, even in today's very large databases in lots of enterprise environments. 4 terabytes would possibly be able to run on Azure SQL database. So as well as the size, the DTUs available change as well. So P1 there's got 125 DTUs, P15 has got 4,000 DTUs available. And as you can imagine, the more you use, the more you pay for. P15 has got a monthly price of around $16,000, whereas P1, the price for a P1 Azure SQL database comes in at around about $465 a month. Now, we've been talking a little bit about DTUs and database transaction units. The amount of resources in terms of CPU, I/O and RAM that's going to be assigned to an Azure SQL database at a particular service tier is calculated in terms of DTUs. Now, DTUs guarantee that an Azure SQL database will always have a certain amount of resources and performance, the performance level is offered under a particular DTU, at any given point in time, and that is independent of other SQL databases on the same Azure SQL server or across Microsoft Azure. So the DTU signifies the power that is available to your Azure SQL database. Now, the ratio of the resources is calculated by Microsoft by running an OLATP benchmark. The DTU signifies how powerful an Azure SQL database is. So for example, if 5 queries take 80 seconds to run on a basic tier. With 5 DTUs, it'll take 4 seconds to run on a standard S3 tier with 100 DTUs. So basically what we're saying there, the more DTUs you have, you're going to get better performance than databases with less DTUs in a given service tier. In this next section, we're going to look at scaling up the Azure SQL database tier to get us better performance. So the scenario is there's an increase in load on our SQL database in Azure. We want to overcome the problem. We're going to change the service tier for the database so it can then cope better with the workload. So we want to scale up the Azure SQL database service tier to get us better performance. Now, in order to do this, we're going to set ourselves up with a toy store database. And there's a PowerShell script in the lesson 2 folder called import azure sqldb.ps1. We're going to execute this script, and this is the script you can see on screen here. It's got a number of variables and parameters in there. So we've got server name, SQLDB, user, password, backpack file, and SQL package. So we're going to provide a server name, a database name, an account, and a password, the file path of the backpack file, and the path of SQL package.exe, and the script we'll use SQL package.exe to import the backpack file as a new database on the given SQL server. Now the database will be created in Basic Edition. As you can see there, the PowerShell script says it's going to create it in Basic service tier, and it might take 10 to 15 minutes to work its way through here from my machine. So I'm just going to execute the script. I'm going to click on OK. It prompts me for a server name. Now my server name in this case is called Toy Store SQL. So let's type that in, Toy Store SQL. The SQL DB is going to be called Toy Store. The user is going to be SQL admin. The password is nothing complicated. The backpack file is here. So I'm just going to copy that, paste into the console. And the path is this one. So it's in Program Files, Microsoft SQL Server 140, DAC bin SQL package.exe is the path. I'm going to paste that in here as well. And then I'm going to hit Enter, and it's going to go away and deploy the Toy Store database to Azure for me. Move this on here so you can see it. Creating a deployment plan, it's initializing the database. And then we wait for 15 minutes. So with our backpack deployed, we can jump onto the Azure portal, all across here. Okay, we can see I've got our Toy Store database. It's on the basic pricing tier and is part of my subscription. In Management Studio, if I connect, put this on so you can see that as well. You can see we've got a Toy Store database with a full database schema and a range of tables included. We just wait for the tables folder to expand here. It's taking a little bit of time. And you can see there we've got our application tables. The next thing for us to do is to stress test the Azure SQL database running on the basic tier. Now, on the screen here, I have a batch file that's making a call to the ostress-test tool as part of the RML utilities. We're specifying a server to connect to, connection information, the database to run the query against, and we've got our select statement. If you scroll all the way across the bottom, we've got a couple of parameters, -n25 and -r. The -n25 run 25 concurrent sessions, and then each session will execute the query 20 times. Okay, I'm going to use the RML utility to do that. So we'll open up the RML command prompt, which I already have here, and I'm going to type in C, my code folder, go to lesson 2, and then I'm going to do my execute query.bat, and I run that, and this query will run against my database. It tells me it's starting, creating 25 threads to process the queries, worker threads created, beginning execution. Run and do its thing and see what output we get at the end. So you can see there, just look at the screen, stress test exiting normally, elapsed time 1 minute and 17 seconds. So the next step is to scale up the service tier from basic to standard S3. Now in the lesson 2 folder in the code folder, there's a PowerShell script here that's going to basically accept some parameters from us, including the resource group name, the Azure SQL server name, the database name, the new service tier, and the performance level. And then there's an Azure file path. I'm just going to kick this script off. In the resource group name, I'm going to put Toy Store RG, which is the name of our resource group. The Azure SQL server is Toy Store SQL. The database name is Toy Store. The service tier is standard. S3 is the performance level. I'm going to put C code for that. Okay, transcript started. It's asking me to sign in, which I will do now. And if you had a JSON file here, you could have put your path, your Azure profile JSON file, so you didn't need to sign in. I'm just going to sign in here. And once we've signed in, go away and modify the service tier for us, as you can see there. Gives us a list of output. Now if I go into the portal and I refresh my portal screen, and I'm going to go to my SQL database here, click in Toystore, and you can see the pricing tier has been changed to S3 standard. So we'll rerun our RML command prompt here, execute query batch that we execute in step 4. Click into the command screen here, and I'm going to type C code lesson 2 execute query batch. And it's executing the same queries. It should complete in a quicker time than we saw with our basic tier. There you go. You can see the stress test this time took 27 seconds to execute the query the same number of times with the same number of connections. So performance is better. So let's learn about changing a service tier. You can scale up or scale down an Azure SQL database at any given point in time. This gives you the flexibility to save money by scaling down to a lower tier during off-peak hours when your database is not being used, and scaling it up when it's under a heavy load, possibly during peak hours. You can change the service tier manually, or you can do it automatically. A service tier change is performed by creating a replica of the original database at the new service tier performance level. The time taken to change the service tier depends on the size as well as the service tier of the database before and after the change. And you may have saw that when I was scaling up from basic to standard in the demo there. Once the replica is ready, the connections are switched over to the replica, and this ensures the original database is available for the application during the tier change. This also causes all in-flight transactions to be rolled back during the brief period when the switch is made to the new replica. So we might want to add some retry logic to our applications during this time. Now, the average switchover time is 4 seconds, and it may increase if there's a large number of in-flight transactions. So the retry logic is going to be potentially very important for your applications if you are going to be using scale up or scaling down whilst the application is live.